Good morning, welcome to my trial version of online tuition. I'm starting with module 3, which is about fundamental electricity, and 317 is about AC generation, AC power generation. And according to the syllabus, module 317, AC generators, it have 5 subtopics. We start with the simple theoretical generator, rotating loop in the magnetic field, and a waveform produced. The second part, we talk about operation and construction and revolving armature or revolving field. These are the two types of generator, revolving armature and revolving field. And we talk about single phase, dual phase, or three-phase alternators. And we focus more on the three-phase generators. In fact, the term alternator and generators have been used interchangeably. And then lastly is about permanent magnet generator. AC generator, if you look at the syllabus, it is at level 2. That means the student are expected to have theoretical knowledge and practical application of the AC generator. And the applicant, this is the person that applied for the license, should be able to give general description of the system and the elements and the component. And if there is any mathematical formula or laws, he should be able to use the mathematical formula, and also should be able to use the calculation, and he should be able to apply the knowledge on the aircraft. Prior knowledge, this is based on my experience. It's not stated in the syllabus, that the student should know Faraday law, Lenz's law, the vector diagram, how to add or subtract vectors, and trigonometry. Normally in the class I will review this, but not in the online tuition because it will take more times. Okay. The principle of AC generators. So this is back to the Faraday law. When the conductor is moved through magnetic field, or magnetic field moved through a conductor, and when the conductor cut across the magnetic field, a voltage is induced in the conductor. The direction of the voltage induced is given by the Fleming right-hand rule. That means if you are using the conventional flow of electricity, you use Fleming right-hand rule. If you use electron flow electricity, you say it is the Fleming left-hand rule. The induced voltage is called EMF, or electromotive force. This is a simple generator to demonstrate the principle of the production of electricity. You have the north pole and the south pole, and you can see the line flux running across from the north to south. And you have the conductor. This is a loops conductor. You can call this A and the bottom part is B. When this top part A is right on the top, which is vertical to the line of force, and this is where the voltage produces a minimum. You know the reason why? Because imagine this conductor is moving in a rotation, but at one point the movement is in parallel to the line of force, so there is no cutting of flux. The maximum is derived, the EMF you get when the conductor is at this point. When it is right in the middle, and the movement will be vertical or cut across the line of force. This is where the maximum voltage is induced. Okay, the same diagram, but in this case you have the rotating loops, you got the north and south poles, and you have the what we call flux running from the north to south. But in this case, two additional components added. You have the slip ring, two of them, and also you have the what you call carbon brushes here. So what will happen is, when this loop rotates within the line of force in the magnetic field, then EMS is induced or produced. The EMF will be forcing through to the slip ring, and it will pick up by the brushes. Here we can see, as I have explained a bit before, the different position of the loops within the line of force and the effect of the EMF. So in this situation, where the loop is perpendicular to the line of force and the rotation is almost in line with the line of force, almost parallel to line of force, at that point the voltage output is 0. But in this situation, where the loop is vertical, the movement of the loop is vertical, you see the loop is moving this way, okay, and it is cutting the line of force at maximum, and here you got the maximum EMF produced. Notice it rotating at anti-clockwise, and here, as far as the line of force concerned, then it rotates from right to left, whereas the bottom part rotates from left to right. And when it reaches 180 degrees, the position of the EMF produced is like when it was 0, like it was 0. And but you notice here, more than 180 degrees, the loop now is rotating the different way in relative to line force. That's why the voltage output is opposite to that. And at 270 is maximum, but it is opposite. Okay. So the factors, what are the factors that affect the voltage output? What are the factors that affect the voltage output? If you refer this to Faraday's law, refer to Faraday's law, it is depending on the rate where the conductor cut across the line of force. So indirectly what it says is, it will depend on the strength of the field. It depends on the strength of the field. The stronger the field, you got more flux per square meter. There is a flux density. More flux density, then you expect to have higher voltage. And the other one is the number of conductor. This is shown 1, but you can have 2, 3, 100, 200 conductors, and all the EMF will be added together. And the third one is the speed of rotation. So 3 items that will affect the output here. Okay, so here is showing the same thing, and on the line force. And I think for the that's about it for this module, which is the purpose is to demonstrate the principle involved in the production of electricity. And we will cover the next module, which is one phase or single phase generator.